Hey kids, here comes a recap on Objective 4, converting a decimal expansion that repeats into a rational number. Basically, we are taking the previous lesson, Objective 4, and flipping. Instead of converting a fraction to a repeating decimal, we will be learning how to learn how to convert repeating decimals into fractions. As I go today, remember this isn't the exact lesson that we had in class, just a recap of the high points. Not a perfect lesson, but hopefully something to get you by if you've been absent or if you need a refresher. Feel free to rewatch parts of this, pause as you need, stop and think, and of course if that's not enough, I'll share with you my email address at the end so that you can get in touch with me. So this rational number basically means a fraction. A rational number is a fraction. And we will begin learning how to convert this repeating decimal into a fraction, first by backing up and talking about terminating decimals, the ones that end. And we had this funny reference to the Terminator, Arnold. His job was to end various people, which is kind of tragic, but the analogy sticks. Terminating decimals, similarly, they end, they stop. For example, 0.3, which if you remember your place values, means 3/10 or 3/10. Similarly, if you have two place values after the decimal, that's hundredths. 27 hundredths has a D in there. And if you have a hard time knowing which place value you're working with, you can count the number of places after the decimal point, and that will be the number of zeros that follow the 1 in the denominator. And it's just a little trick that you can use if that helps you. So for example, there's 1, 2, 3 places after the decimal, so 1, 2, 3 zeros after the 1, and the numerator would be 123. We would read this 123 thousandths. Okay, now we would read this 22, not 22. And it would be hundredths, tenths, hundredths. And what happens when we do this, we get 22 hundredths. You'll realize that both of those are even numbers. They're both divisible by 2. And so I can simplify those to 11 over 50. Now, we stopped at this point in our lesson to refresh students on how to use the TI-34 multi-view. Of course, it's ideal for every student to know how to do this independently without a calculator, but just to demonstrate how you can do this with a calculator if you needed to, this is your fraction button for 22 hundredths. Remember to hit the right button to end that fraction. And to simplify, you'll push the simplify button and enter. And there's your 11/50ths there. Okay, if we have a whole number greater than 1 or more, if we have a number that's 1 or greater, sorry, I'm tripping on my own words, we would say 1 and 19 hundredths. This is going to create for us a mixed number in fraction form, so 1 and 19 hundredths. Hopefully that's a review for you. If it's not, we've just created for you a one-page reference that you can refer to in the future. And so let's continue with the new information. Going into repeating decimals. And again, this is just the opposite of what we did in the previous lesson. So we learned before that 5/9 is the same as 0.5 repeating. It's a single digit over a single digit, and the numerator is what is repeating. So therefore, the reverse is true. 0.5 repeating is 5/9. We see that it's repeating, it's one digit, so it'll be a single 9, and what's repeating is in the numerator. 25 over 99 we learned is 0.25 repeating. This is our repeating part, so it is our numerator. 2 digits that are repeating, so it goes over 99. And here, again, we learned that 251 over 999 is 0.251 repeating, so The reverse of that is also true. This is what repeats, so it becomes our numerator. 3 digits are repeating, so it goes over 999. And so that is our pattern that we can follow for that. Now, I would like you to please take a moment and work out these questions. Push pause now, and then you can start up again and get a recap of the solutions. All right, welcome back. So we have 0.32 repeating, 2 digits, so over 99. What is repeating? 2531. So it's our numerator. 4 digits repeat, so our denominator is 9,999. If you have a 0, please do not drop it, keep it. This is a placeholder 0. If we just dropped this 0, our 206 would become 26, and that's different. 3 digits repeat, so it goes over 999. Also, if I have a repeat in digits, we need both of them. If I dropped the second 3, this would indicate 0.23232323323. I need this 3 here because now it's 0.2332332332333, which is different. When you have a whole number, bring it out front like this, and the only thing that repeats, of course, is this decimal. So we write it like that. Now be careful when you're doing this to simplify. Now, you may notice that both of these numbers are divisible by 3, but you might not. So it's wise to go through your solutions before you are completely finished to double check to see if they can be simplified. And if you can do that in your head, great. If you can't, then use the simplify, enter. Now, if you see this arrow come up, that means it can be simplified even further. So hit that simplify and equal once again. And so now that we don't have an arrow there, we know that the simplification is done. Again, remember to simplify. Here we see a question set up for the park or the IAR, however you call it. This is just the same skill, what fraction is equivalent to 0.4 repeating. And you'll need to write an answer in this form. And so it's important that you get kind of acclimated to these tools that are offered to you on the park test. This one is kind of set up a little bit like the fraction button on your calculator. So that would be the tool that you would use if you were to do the IAR test. Okay, this last page is a bit of an enrichment. This is one of my favorite conversations that we have in math class. This isn't something that I expect students to be able to rattle off independently, but I do challenge you to follow along as long as you can. So I do like for students to know the justification for the rules that we learned. So on the previous page, you learned the shortcut trick that you can use to convert from here to here. You know that if it's 99, that it's repeating, and then I can just do this trick of that's my numerator and it repeats. But why? So this conversation is a justification for why it actually works. So to do this justification, we're going to be using an equation. You might be somewhat familiar with the equations, where what you do on one side of an equation, you must do to the other to keep it balanced. So let's say, hypothetically, we have a number represented by n, and it is 0.8, repeating. Now we have learned that that could also be represented like so, right? It means the same thing, just a different way to write it. Well, let's just say, hypothetically, that I'm going to multiply each side by 10. What I do on one side of the equation, I do to the other to keep it balanced, and I'm left with 10n equals, I multiplied this by a power of 10, so I'm going to move the decimal point 1 over, and that will be my result. Now let's say from there, I would like to subtract off 1n, like so. Subtract an n, and what I do on one side, I have to do to the other. 10n minus 1n is 9n. But I can't subtract a variable from numbers. So what I can do instead, refer up here, n is equivalent to 0.888. So instead of this, I'm going to subtract 0.888. 8. It means the same thing, kind of like 4/4 is $1, right? So let's see what's left. 8 minus 8 is 0. 8 minus 8 is 0. 8 minus 8 is 0. 8 minus 0 is 8. And so we simplified our equation up to this point. Now, if I have a variable with a coefficient here, they are joined together with multiplication. The reverse of multiplication is division. Divide both sides by 9, and I get, voila, n is 8/9, which we know. If I were to convert 0.8 repeating into a fraction, it would be 8/9. It's a really interesting conversation. If you were able to follow all of this, part of this, congratulations. My goal for you is to latch onto something new that you don't yet know that you can apply in the future. So your homework is based off of your notes, and so you should be able to follow your notes to complete this. So this would be the beginning of your notes, and then partway through, most of the way through, and so this stuff comes from more towards the end of your notes. So the instructions here say to convert these repeating decimals without a calculator. So again, we'll just hop over to a new one. We have a number greater than, or 1 or greater, so there's the whole number. 2 digits repeat, so they go over 99, like so. The next section, again, says to convert without a calculator, but then it reminds you to simplify. The biggest problem that I see students have is they neglect to simplify, and I think all but about 4 or 5 of these can be simplified, so please pay attention to that. So, for example, 2, 1, and 3 would go over 999 because it's 3 digits, and if you use your calculator, 213 over 999, simplify equals 71 over 333, and that would be your final answer. Be careful, too, if you have a negative, to bring that negative over in your solution. Now be careful that you remember to go back and simplify that one. All right, kids, if that was helpful, I am glad. If it wasn't, don't be bashful in getting a hold of me. Always happy to help. You're not a bother to me. Thanks a bunch, and I will see you guys in class. Bye.